So here's the module I sent you, no? Chem 41. So this is like a foundation of uh chemis foundation of biochem, and specifically for buffer. So you can check here, no? How to use your Henderson-Hasselbalch, and you have your buffer capacity, your buffer range. No, you can check this after our session. So additional info. Ito ay summarized na by Ma'am Patsy. Okay?
It's good.
Then let's go to the one you sent me. Let's go to your Okay, so buffer prep. Mm-hmm. Ano to? Ay, sorry. This okay. Oh, what's wrong with number one? How do you prepare a buffer? Sige nga.
How do you prepare a book? Well,
So how do you prepare this? Like just describe, or if you can calculate on your end, paano mo kinalculate?
okay, so to get a buffer, you need to choose like something similar from the table. For example, letter A asks for a pH of 2.0. So you need to
Mhm.
find something similar. So you're gonna choose phosphoric acid, which is at 2.15.
Correct. Mm.
Yes. Then you use the Henderson-Hasselbalch equation.
Mm. So I have a question. In Henderson-Hasselbalch equation, do you need a weak acid or a strong acid?
Weak. It's always weak, right?
Because
Because it won't pH is usually it needs to be weak because
mm, because what? Because why?
does it have to do with pH?
Yeah, because we're talking about pH.
Um,
Oh,
it needs to be weak for the buffer
yeah, yeah. That's the general concept. I need the specific answer.
because
Tatanungin yan. Oo.
buffers are resistant to I think about buffers, they're resistant to something. What was it?
To the change in pH.
Yes,
Okay. So one thing to remember, when you need to prepare buffers, you should have a weak acid, and it's what?
a weak base. Conjugate base?
Correct. Conjugate base. So I guess the conjugate base is stronger than the weak acid. So what happens is, as you add a titrant or something, no, to the solution, there is no drastic change in pH. So a good pH has the range of, I'll annotate. I'm just using my pH. Ay, teka, pwede pala dito yung text. Okay. Okay, pH equals to pKa plus or minus, I think, 1. So
Yeah,
for example, for letter A, you need a pH 2, right?
yeah.
You need pH 2. So at pH 2, you can choose phosphoric acid, no? Kasi the right buffer, or the right weak acid or substance that you can use should has the pH ranging pKa plus or minus 1 or 0.1. But I guess 1, no? So can you use, when you compare citric and phosphoric acid, which is more valuable to use?
Uh,
Phosphoric,
sorry.
citric.
Sorry.
Oh, correct. Phosphoric. Kasi, di ba? From the difference is just 0.15. Okay?
Yeah.
You can also use citric, pero if we are being practical, we can use just phosphoric acid, and mas madali siya. Huh?
Okay, why is it practical exactly?
Because when you compare 3.13 to 2.5, 15, pKa1,
Yeah.
pK1, it's nearer than it's nearer to pH2 than pKa3. Okay, so how would I'll just type, no? So for example, you're looking at pH2, no? So what's the pKa of phosphoric? 2.15,
Yeah.
no? 2.15
0.15.
plus or minus 1. So compared mo kay citric, let's say citric, uh 3.13 equal to, ah you know naman the difference, right?
Yeah.
You know the difference. Di ko nasulat. And you're right naman. Nasagot mo naman kanina.
Okay.
Okay, so review. What do you what do you need in making a buffer? What type of acid and base? Specific acid and base.
Weak acid and conjugate base.
Which is stronger?
The conjugate base.
Hmm. Okay. So I assume you know how to use your hand.
Hello. Oh, it froze.
How to use. Ah, akala ko nawala ako. So I
Scientific
so
calculator?
I assume you um you can try. Try naman. So okay, so how did you solve?
Okay, so
How made letter A? Mm-mm.
Henderson-Hasselbalch equation. It is pH equals pKa plus log.
Mm-mm.
Is it base over acid?
Hmm.
It's base over acid, right?
Correct. That's correct.
Okay.
Yep.
So so
So
pH. Can I
mm,
annotate? I can annotate. Okay.
yep. You
Do
can.
2, 0, 8.15. Okay, so it's that.
Okay.
Then, so 2.00 minus 2.15 is 0.15 equals log over base.
Mm.
Okay. And then log over base. So you need to get the inverse of 2.00. Sorry, 0.15. Sorry,
Mm.
logarithmic inverse. Logarithmic
Is it 0.15 or negative 0.15?
or negative because it was transferred to the other side, right?
Correct. Okay.
Uh,
Teka lang.
wait, you can't, come on, you can't erase it after you put it there.
Yeah. Teka. Ay. Oh, sige. So we can ano. Go lang. Annotate mo lang.
Okay. So negative 0.15 inverse logarithm inverse is
Ito lang mahirap no pag online. So like when face to face, we can just have it written on the faculty lounge. So I
yeah,
can kind of draw. Or siya, can I see your annotation, please? I don't see your annotation.
there. Is it there?
Okay.
There.
So how do you do the logarithmic inverse?
You just get the scientific calculator. Why? Do we have to do it without it?
So you just state it to me. Something raised to something equals to 0.70, right?
Yes.
So 10 raised to negative 0.15, right?
Yes.
Okay. So you got 0.70. So what is this 0.70? It's the
The
fraction of the concentrations of your what?
buffer?
Yeah, specifically your what?
Phosphoric acid.
Yeah, so specifically what? Your phosphate base and your phosphoric acid. O sige, you're correct naman. Pero I'll show you the steps, no?
Okay.
So 2.00 is equal to 2.15 plus log of your base, conjugate base, so over your weak acid. Okay?
Okay.
So when you transpose, it would be 0 negative 0.15 equals to log of this, right?
Yes.
Yeah. So what happens is 10 raised to negative 0.15. So I assume you did this, right?
Yeah.
It's equal to your what?
Uh,
Conjugate acid, conjugate base over weak acid. So let's say, para nahihirapan ka kasi kapag hindi base over acid eh. O, base over acid. O, palitan natin to. No? Okay. Oh, shoot. Wait.
yeah,
I
you can't erase
can't
it after.
edit the ano.
It's fine. It's fine. I get it. Conjugate base weak
Okay.
acid.
So you get 0.70. So it's very important, no? I'm teaching you the step by step. So you have your base over acid. So what happens is once you'll have this ratio of, you can transpose either A or B. B. Ayan. So what's next
Well,
after this?
let me get my book.
So you have your wait. So you have your total concentration, right? Oh wait. I think my laptop's hanging. Wait lang.
It's okay. I'll look from this thing.
Okay. So what's next
Um,
after we got this? Anong gagawin mo?
so I'm reading the notes. So next we have to substitute it.
Substitute 2.
0.1, right? Because that's what it's asking.
Yep. Wait lang.
I'll just go back to this thing.
Wait.
Um,
My laptop's hanging. I can't uh, press my Windows. Wait lang ha.
okay.
Shoot. Why okay. I'll just X. Ayun, okay. So, ang sabi dito, you need 0.1 molar. So, you have a 0.1 molar. So, let's say that's the given. How do you how do I change the color of my text? Okay.
Yeah, I think you just
So, your given is 100 ml. 0.1. Yan, di ba? O, anong gagawin? Anong gagawin next? Given this ratio. This one. Given that, anong gagawin dyan?
100 ml of 0.1 pH of 2. Uh, hmm.
Can you see my cursor? By the way, can you see my cursor?
Yes.
Okay. Sorry, nawala. I'll go. No, okay. Sige. Oh, my God. The sun is shining down here.
Okay.
Oh, what's next?
Okay. So 0.1 equals
Oh, sige, you annotate on the right. I
okay.
annotate on the left. Kasi
Okay.
it's best if you write it when you write it because you practice yourself on solving. Huh? That's
Okay.
a technique rin. Go.
Okay. Okay. Now my question is, so is it base first? Or like it can be either, right?
It can be either.
Yeah. And then base plus 0.70 over, and then there's the acid, and then it equals. So what happens is base and acid adds to each other. So this goes from 0.1 equals 1.70. Like that, right?
Correct. Okay. So 0.1 equal to okay, sige, magsulat ako. You're correct naman. Di ka
Okay.
nagsulat. Okay. So what happens is you have 0.1 equal to um by natin. Okay. 0.1, no? So you have your acid and your plus your base, no? 0.1 plus 2. What's A? Oh, what's B na lang muna? B is 0.70, no? A plus 0.70A. So when you add them, is equal to, you're correct, 1.70A. So what's the concentration of your acid is 1.0.1 divided by 1.70.
Ah,
So what's the answer? I don't have a calculator with me. I give it to my brother because he needs it.
0.06.
Okay. Here, let's assume that this is the correct answer. Oh, how about your base?
Well,
0.70 times
0.78 times 0.06.
correct. Very good. Oh, what's the answer?
0.0420.
Okay. Hmm. So this is your um phosphoric acid. I don't phosphoric H2PO4, I guess. The first pKa. Then when you remove, di ba? HPO4 raised to the 1 negative. Okay? Sana tama ako. Don't cancel me. Kasi um, wait, okay. Okay, I'll have a question. It's quite conceptual. Why did I put HPO4 raised to the negative 1 here? What happens here to the
Recently,
phosphate, the monophosphate?
the monophos. Why is it negative
This
1?
is yeah, this is a monophosphate. So from your phosphoric acid, which has a formula of H2PO4, you lost an acid, which at pKa1, sige, illustrate natin ha. So H2PO4. So you have your arrow, no? HPO4 uh, raised to the negative 1. So what happens here is, okay, you have your pKa of pK1. What's our pK1?
Uh, would it be the
Anong
1.7?
pK1 natin? 2.15. Okay?
Oh, okay.
So at peak, okay, sorry. Ayan, ngayon ko lang kita. Okay. Anyways, I'll explain this para maintindihan mo yung process. So at H2PO4, your pH is less than your pKa. So the existing form of your acid is phosphoric acid with two hydrogen atoms or bonded with your phosphate group. Okay? So this is H2 H subscript 2 PO4. Wala kasing subscript dito, I guess. Okay? So at pH greater than 2.15, let's say at 2.151, let's say either 2.151, 2.16, no? at those pH, it's greater than your pK1. That means
Okay.
that the pH or the pH is higher than your pK1. So I think you know naman this.
Okay.
I'm
So
just
it's
I'm just visualizing you. Um, ang nangyayari, mawawalan ka ng another hydrogen. So kaya magiging -1 ito kasi you lost an hydrogen.
okay.
Do you get my point?
I get it.
So what happens at pK2? Anong mangyayari? Can you annotate on your end?
What happens
Sige
to
nga, conceptual. O, pK2 naman.
so if pK1 is 2.15, pK2 for phosphoric acid?
Yes. Kasi ang system natin from the beginning, we use phosphoric acid, right?
Yeah. Oh, okay. I get what you're doing. Okay. Well, the table says 7.20, but I don't know how we reached 7.20.
Okay. So, you just follow, no? From here, new color, you'll have your arrow again, which is, ang mangyayari, PO4 raised to the -2. Okay? So,
Okay.
you lost another electron, no?
Yeah.
And what happens here is this is your pK2 now. No? pK2 of 7 point something something. Okay?
But how? How did it become 7?
It's because it's on the table values. So going back here, no, it's 7.2,
Yeah.
no, 7.20 actually.
That is given.
So going back here, at pH less than 7 or 7.2, the predominant species is HPO4, no, majority, and a little of, I guess, this, no. Pero at pK2 greater than 7.2, let's say 7.3, 7.4, 7.215, the hydrogen is now being removed from your second predominant species,
Mm.
huh? To form your PO4, your phosphate alone with no hydrogens bounded. So I guess if sorry mali ako no. Let me just correct. So dahil tatlo ang pKa nito, it means that your phosphoric acid has atoms. Yun ang nakalimutan ko doon. So you get my point? Okay.
It cut.
How can I delete this? This is wrong. Okay. So ay nawala yung iba. Ayun, okay. So ayan. So okay. Wait a minute, kaping mainit. Nawala si Gerald.
It cut a while ago. I couldn't
You
hear.
still here with us? Still with us?
Hello.
Oh, wait lang daw. Sige.
Um, that last sentence you said cut. I wasn't able to hear.
Oo nga, H3PO4. Hindi, tama. Hindi, H3PO4 ba? H2PO, hindi, tama lang H2PO4. H2, hindi, tama, tatlo. Tatlo. Sorry, let me check. Phosphoric acid, formula. Huwag niyo po i-cancel. Hindi ako genius. For those who will use this as reference, ayun, H3PO4. Wala naman po masama mag-search, okay? Gerard, are you still with us?
Yeah. Can you hear me?
Yes, okay.
Okay.
So, okay. So the predominant species of phosphoric acid is triprotic. Triprotic, no? Triprotic, which is H3PO4. H3PO4. Triprotic. I know naman, no? Monoprotic. Okay. So, delete na natin yung iba. I'll delete your ano muna ha. Kasi we need space.
It's okay.
Parang sa UP, we need space. Oh. Okay. Okay, I'll annotate here. So that's your first triphosphate. That's your first pKa. No? H2PO4 and then raised to the negative 1. Cause you lost what? How many hydrogen?
Oh, you lost one. Wait, I need to.
Okay,
Someone's calling.
very good.
Wait, someone's
For
calling.
the next pKa, I guess you will lose another electron. So it will be 2 negative. Okay? Teka lang, bakit sobrang lapit niya? Okay. And then for the next one, you will lose another. Ay, mali. Okay, you will lose another electron, no? Which will be PO4 negative 3. Okay? Para hindi ka mahirap, para madali sa ating viewers in the future. This is negative 2. 2 negative or negative 2, no? It doesn't matter. It just means that it's a negative number. So sometimes you can use 1 negative or negative 1, either of the two. But for the sake of our tutorial, no? Ayan, ganyan siya. So, syempre, ayusin natin. How can I edit this? Okay. Ayun, very good. Ayan. So, kasi tutorial pala recording to. So, pwede natin magamit to in the future. Okay. Ayan. So, um, teka lang. I-move natin tong mga, oh. How can I move everything? Okay. Move muna natin to kasi babalik tayo. Di pa tayo tapos. Magtutuos pa tayo dito later. Okay. So, this is your okay, PKA1. PK1 actually. So PK1 and then PK2, then your PK3. Okay? So looking back to our table of values, balik tayo, no? So this is your table values. 2.15. Teka, sulat ko lang. 2.15, 7.20, and 12.35. Okay. Okay, annotate again. I'll mark it red. This has a value of 2.15. This one, 7.20. And this one, 12.35. Naturo ba na ganito yan?
Did they teach you this?
Teach you this method? Like, how does pKa affect pH? Did she show you something like this in the lecture?
No, this is during lab, actually. This is lab.
Okay, during the lab, but did you understand before our meeting?
No, this is I remember something like this, but
Did you understand?
now it's actually explained to me.
Oh. Okay, very good. Okay, I'll further explain. So, same goes, no? So, at pK3, at pH 12.35, you have the predominant species. You have your species, monoprotic phosphoric acid.
Mm,
So, at greater than 12.35, no, the H here will be removed to transform into your phosphate.
mm,
So, you know naman that phosphate is a part of many biomolecules. The most famous one is adenosine triphosphate. So, saan siya ginagamit, no? Adenosine triphosphate is the what? Fuel of our cells. So, what happens is it's resonance stabilized and it's a currency on doing cellular work. What happens is as you transfer a phosphate group, you create multiple um organ the transfer of phosphate group, no, from adenosine triphosphate to adenosine diphosphate, from 3 phosphates to 2 phosphates, you can create certain molecules from those transfers. Yun lang naman ang ibig kong sabihin sa phosphate. In this case, this is an inorganic phosphate, yung nasa pK3, this one, and this is a phosphoric acid. So it's in its acidic form, at which is in a common sense at around pH 2. Okay? So as you increase the pH at 12.35, it will be a phosphate. It will be just phosphate. So do you understand the essence of pKs?
Yes.
So unlike sa lab, o sige, bigyan pa kita ng background. So you have kasi yung dissociation constant of water, right? Ka over Kb. What does that mean? So you have a dissociation constant of water, which is equals to your acid dissociation constant over your base dissociation constant. So dyan po nanggagaling si ating Kb. So si Kb is equal to Kw over Ka over Kw. And when you get the negative log, I guess you will get pKb is equal to power of the everything, okay? Hindi ko na
Okay.
isus. Anyways, ang purpose lang naman, kaya no, sorry. pKa pala tayo. Okay, my mistake. pKa. So pKa, you just have to transpose equal to the, I guess, negative log, no, of your Kb times Kw. Oh, advance ka sa classmates mo. Diniscuss ba yan?
No.
Oh, yan lang ang basis ng pKa. So you have a negative log of your Kb times Kw, okay? Ang trip lang yan. So from that, ito yung nangyayari, no? And then your Henderson-Hasselbalch equation, pKa plus log of your base over acid. Okay? The parenthesis is just meaning the concentration, no? When you see something like this, it means the concentration of B. Let's say this is B. Okay?
Okay.
So kaya dito, no, kaya in this part, we use CB's conjugate base, concentration of conjugate base. Okay, so let's go back to our main problem. I'll delete na to. So, do you understand the concept of pK na? And this, no, madali naman. Okay, o sige, delete natin. Okay, let's go back here. Oh, come on. Teka lang. Come on. Okay. 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 So if my calculations are wrong, at least alam mo yung steps. So, that's the concentrations of your acid and your base. Okay, so from here, how will you create this? How will you create that? You answer on the right.
How to create a pH of 2?
Yep. Based on what we got right now. What we got a while ago.
Okay, well, again, so I'm just basing this off the stuff I did before. So to calculate the volume needed, we need the mass of is it the base or acid? Or is it
Yep.
the mass of the acid? Times 0.1 times 9.
So do you have the values of those? Let's check.
We need to like find the
Oh, I'll just get my mouse. You solve
okay.
it. Try to solve it first. Find
Okay.
the grams of your acid and the grams of your base given the concentration. Tama naman, no? When you add the concentration of your acid and the concentration of your base, it's 0.1, no?
Yeah.
Actually, it's 0.120. So maybe the concentration of your acid is less than 0.06. So let's say around 0.0580. Kasi when you add them, it should be 1, right?
Hmm.
So let's baguhin na lang natin ito. So, shoot. Okay, okay, okay. Chill. This is your age. So correction again, This is this is H3PO4 and this is H2PO4. Okay, correction for that. For all the viewers, if you'll be using this, correction po dito. And this one should. Okay. Oh, time's up. Oh,
Yeah,
sagutin mo.
this one, right?
3 minutes na yun.
Yeah, I'm done.
Oh, go.
This
How
is
did
it?
you manage? How did you solve it?
There. Oh, it doesn't upload yet. Okay.
Ah, okay.
We're trying to find the mouse, right?
Okay. Oh, very good. Oh, so explain to me how will you create the buffer? Sige nga, with the reagents, with the equipment, with the glasswares. Yun ang final.
Okay, let me remember. Because we had it last Tuesday. So um
O sige, bigyan kita ha.
so first
Bilis,
we
bilis. Go.
okay, so first we got I so it's that that thing where it's like
Volumetric flask.
no, not that. It's the well, first we
Beaker.
prepared the volumetric flask, we prepared the beakers, with all the water, we washed it with distilled water and stuff like that. But there's this like box thing where like you lift up the sides, and that's where you get the
Box thing?
yeah, it's like a
Ah, reagent box.
yeah, I assume it's for the reagent, and then you get the reagent, sodium phosphate. I remember when I went to sodium phosphate,
Oh, correct.
and then that's where you I think when you count you get how much grams based on how much is needed for the buffer.
Okay. Mm-hmm.
So you got that, and then you pour water on it until it dissolves, and then you
Mm-hmm.
check for the pH so that it has the same value as the teacher wrote it on the board. So like we needed a value of 7.4. So we just kept adding water until it reached the pH of 7.4.
What?
Okay. So we put the sodium phosphate into the beaker, 100
Mm-hmm.
ml beaker. Then we poured the water. I think it was like distilled water. We poured the water into it and to calculate the pH until it reached the what the teacher wanted, which was 7.4.
Mm-hmm.
Yeah, and then that's it.
Okay. So you're
Is
partially correct, pero I'm looking for specifics. O sige, for the purpose of ano rin, ha? We
Okay.
are sa page 2 lang hindi tayo 7.4.
Okay.
So, if pwede rin naman, same process with 7.4 but we're focusing on page 2. So,
Okay.
you get your acid, the mass of your acid. Can you see my cursor?
Yes.
Okay. You have your acid, no? You have your base.
Yeah.
Okay. I write it for you. So, you have your 100 ml. Okay. Bakit nakabold ito? How can I... Paano maano yung text? Ba't nakabold na siya? Anyway, so 100 ml vol flask. Okay? Prepare ko ang reagents. Okay? You have your how many grams? 0.587 grams of your acid. 0. Um, let's say 39 grams of your base. You have your glassware of your beaker. 100 ml vol flask. Okay? And steering rod. Oh,
Mhm.
ano pa? Distilled water.
Yeah.
No?
Well,
Okay.
the beaker was 250 ml.
Yeah, it doesn't matter as long as you mix this. Oh, sige, let's say ginamit nyo 250 ml, no? So,
Okay.
sige, from this, step by step. What is the purpose of your steering rod?
To mix it.
Um, yeah, it's common sense, right?
Yeah.
Teka lang, bakit hindi ko ma-edit?
You can't edit once you press it, I think.
I can't edit the
Yeah, once you
annotation. I can't edit the annotation.
yeah.
Ay, okay. Kasi ba't naka-bold? Okay. Okay. Yan,
Okay.
reagents and glasswares. Okay. Delete na natin to
Okay.
Kasi banat to. Okay? Uh, and it's recorded naman. If you need the recording, send lang, let's just ask Ma'am Jo. Okay?
Okay.
Okay. So, you have those, no? And you calculated that these are the reagents. Okay. Distilled water. So, what's the first step? Mix, no? You mix with water. Mix in beaker with water. Okay?
Mhm.
You have your 0.587 grams of your acid plus 0.39 grams of your base. Okay? So, afterwards, once it dissolves, no? Meaning, everything is dissolved in your, transfer to where? Where will we transfer it? Gerard, saan natin siya ita-transfer? Kapag na-dissolve na siya sa beaker.
Volumetric. Um, you place it in the flask, right?
Correct. Transfer to, very good. Sabi ko na fast learner ka Teka lang. Palitan natin yung color. 100 ml vol plus. Okay? So, schematic, you have your beaker, no? And then, you put A and you put B. Actually, you can do it separate, no? And then, lastly, you mix it with water.
Mm.
Okay?
Actually, there was another part, I think, because there's other people where they had to it involved like acid, hydrochloric acid. So the teacher said first
Ah,
pour water and then
uh, yeah, I guess pour water on acid, not acid on water. But just to summarize, you have
yeah.
to basically mix this, right? So, fundamental na yun. Shit, nakalimutan. Sorry po. I guess na, basta it's either you add, I guess, acid on water or acid on water or basta ganun. Anyways, let's go back. Um, Vol flask. So, how does this happen? Okay. So, this is your vol flask. Pangit. Anyways. And there's a mark, right?
Yeah, yeah.
There's a mark here. So you put this, let's say your beaker, you put it in the vol flask, no? And then afterwards, anong gagawin? Afterwards, say, fill the flask with what?
With
So after you put the mixture, the
yeah,
solution, you will fill the 100 ml the full flask with what?
more water, right?
Yep, until mark. Correct. So the answer
Why
is
doesn't that change the pH?
water. What?
How come? Because right, like before, we were really careful with how much water we poured so that it reaches the correct pH. How come adding water into the flask doesn't change the pH anymore? Or
Yes,
like why?
because we already calculated the right amount of your acid and your base.
Okay, so adding the water to the flask is inconsequential. It just doesn't.
Yes. Yes.
Okay.
Why is that? So later you'll find out. So this is the mark, no?
Yes.
And then you add water. Okay, afterwards, so okay, then ang laki naman. Number 3. Oh, what's next? That's it.
That's
Uh
it.
no, 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 no. So before you fill it until mark, you check the pH. If it's around um 2. So if it's not around 2, like for example, you get 1.9, 1.8, you add a little of hydrochloric acid or your sodium hydroxide. And
Okay.
then you check the pH, no? These are just additional.
Okay.
Add appropriate HCl or these are buffer adjustments. So usually these are at lower concentrations, okay? And then check pH with what?
There's like a
With
little like pen thing.
pH meter, okay?
Yeah.
Yeah, the pH meter. Okay, pH meter with pH meter. Okay. So how do you do that? So you have your okay. So before you pour it to your flask, you have your beaker, right? So if you're confident that your methods are okay, you don't have to do 3 and 4. Okay? Pero if you want to make sure before you pour it into your flask, you have your mixture here, you have your A plus B, no? And then you have your pH meter here, no? And there's a reading here, reading pH. Let's say if it's pH 1.8, you pour acid or base to
As
increase the pH. To increase the pH. If you want to increase the pH, you put what?
the base.
Correct. You put a base. Let's say, yung pH niya naging 2.4. Ang layo sa dos.
Oh,
What
so
will you put?
that's when I use the acid.
Correct. Very good. Ang
Okay,
galing
all right.
mo. Acid. Okay? Final reading, let's say around, okay na yan, 2.1. Sabi mo, okay na yan, sir. 2.1 na. At least it's closer to pH 2.
Okay.
Do you understand how to create a buffer solution now?
Yes. So that's so in the thing I sent you, that's everything you need to do for that one thing.
One item. And for the rest, it's the same.
Okay, good. That's as long as I understand now. Okay.
Okay. So there would be other cases when you will be when you use there'll be other cases when you use, like for example, not a solid substance, when you use a liquid substance. But that's for a different time. So usually when you have a buffer, the most perfect thing that you do is you have your salts, no, in solid form. So you just have to calculate the grams of your acid and your base. You mix them with water, Once you mix them in a beaker, you check the pH. Once the pH is not or far from the pH that you wanted, you adjust it with a base or an acid. No?
Mm.
So that's for 3 and 4. Okay? So
Okay.
basically, if you need 7.2, same process. So from theoretical to the practical process, you now understand how does PK works and
Mm.
how we uh, prepare buffer solutions. And once your professor calls you, when you go to class, you will know how to get the reagents now, the grams of your acid in your base. Correct?
Yeah. Yeah.
Okay, that's good to know. Oh, do you have questions before we move on?
No, no questions.
Okay. Sige. Let's delete all the annotations. Okay. If you want to take a screenshot now, just a
Okay.
summary,
All right.
you go. Okay. Clear ko na ha.
All right.
We can go to the other uh, items. So we'll end at, I guess, Miss Jong, hanggang what time po? 4 or 4:30? Okay na naman 4:30. So, pero I guess, oh, ito na pala yun. So, yun na pala, tinuro ko na.
Yeah, that's what I was.
I thought 3 onwards are different cases.
No, no. That's what I was saying. I was saying like so everything. Yeah.
Ayan pala eh. Oh,
Yeah.
one molar nga dito oh. 1 molar HCl or 1 molar sodium hydroxide. Oh, mine is a schematic. You
Yeah.
have visualization in mind. Unlike this. What the heck? So, in biochem kasi our training is to do a schematic diagram, no, where you have to create to think of the process in mind and you have to illustrate it based on the procedures.
Hmm.
I guess you have your pre-labs naman before you have your pre-laboratory work, right?
Hmm.
Or your
Yeah.
main experimentation.
We have a pre-lab first, and then we have the experimentation after.
What I mean is here is an example of a pre-lab. I'll show you, no? Typical pre-lab for oh shoot. I'll just pause my shares. Pausing share. So oh sige. Okay. Okay. So actually no, oh this is my thesis. So that's a pre-lab. So schematic, you have your reagents, o standard water extraction. Ayan lang naman siya. So you have your workflow, no? Samples, you extract them, your characterization and titration. So you prepare your buffer and then yan, step by step. Oh, and then the reagents as well. Okay?
Okay.
For those who will be using this video po, no, disclaimer, wag po nating ilabas dahil sa thesis ko ito. Although by the time na ano naman na to, patented na hopefully. Anyways, let's go back to the main problem. Oh, yun lang pala eh. So, I guess I thought everything that you need to know. So, you just have to, ano, ayan to, oh, meron nga si Ma'am Patsy eh, other types. And then, identified buffers, goods buffer, no? Ayun lang naman. So, um, do you have more? Okay. So, do you have questions?
Hmm. In terms of buffers now.
So, okay na.
Yeah.
Are we okay for the day?
Oh, wait, let me open.
I'll go. Next. You still have an hour, I guess, or 45 minutes.
Yeah, it's like 45 minutes.
Next. Sige. Ay, kita mo yung kachat ko.
I can either talk, so there's these, so the teacher segmented it. There's like part A, weak acids and their conjugate bases in solid form. Then there's part B, one of the reagents in aqueous slash solution form. But I don't think there's time for that. I think this is too long, right?
For aqueous solutions, it's I yeah, it's quite longer pero
Like it's fine if it's not, because there's another thing I want to talk about.
Pero I can give a scenario kasi diniscuss rin siya sa akin. So,
But like another thing that would help is because I also put it in the when I asked for the tutorial. I need like a review on nucleic acids.
okay, let's go. Sige, tingnan natin.
Okay.
So, which topic
I
on
just I just need
Oh my
I,
God. Oh, wait. Mga private message ko. Diyos ko. Let me... Ma'am Jo, pa-edit na lang yung... Minsan may mga chikahan kami. Pa-edit na lang po. Pero wala namang cancelable.
it's just yeah, it's just
Uh, uh, I'll look into the file you sent us. Okay.
did I
So,
send
what
some?
are your specific questions in nucleic acids?
I just need a review. I just it's I
Okay. So, nucleic acids, you have your... Uh, wala naman dito. Puro buffer to eh.
yeah.
Sige. Ah, puro buffer to. Nucleic acids. Okay. Nucleic acids. Let's just search for a module because we have more time. Okay. Okay. Uh-huh. So, ayan. So, we are in NIH and let's just scroll through it, no? So, basically, this is the structure of your DNA. So, what's the difference of DNA from RNA?
T is replaced with U. Thiamine is replaced with uracil.
Yep.
Yeah.
So from the term deoxyribonucleic acid, what lacks on the nucleic acid at DNA? What lacks?
It is deoxygenated.
Okay, very good. So what are the parts of the DNA and our DNA first? Oh, dito tayo. You can annotate if you want to. What are the parts? I label and you actually andito na eh. You have your base pair, you have your sugar phosphate backbone, no?
Hmm.
And the base pairing are A to T, C to G. Okay. So what is the rule that determines the number of adenine is equal to the number of thymine pairings? The number of cytosine should be equal to the number of pairings of guanine. What is that rule? Basic chemistry.
Is it the central dogma?
No. Start with C.
Just like
C's rule.
C's rule. C's rule.
Oh, H.
Chatulus.
No. Oh.
Char.
Charga. I don't know the spelling. Oh, it's his rule, ha? Tandaan mo. This
Okay.
just means A equals to T, G equals to C. Basic.
Okay.
Okay? So as you can see, no, your adenine and thymine, okay. You have your purines and you have your pyrimidines. So what are purines? Rag and picot.
Okay.
So your purines are what? Your adenine and your guanine.
Now go ahead. Oh,
Your
okay. I see
adenine
it.
and your guanine. And your pyrimidines are your cytosine, thymine, and uracil. In the case of ribonucleic. So this is your uracil.
Okay.
Okay? So as you can see on the structure, no, adenine and thymine are bonded by double bonds, while cytosine and guanine are bonded by triple bonds. Okay?
Hmm.
I'll check or I highlight a part, no? Determine lang kung ano siya. So as you can see here, no, which of the following bonds are stronger? AT or GC bond?
GC, right?
Correct. Bakit?
Because they're more bond, there's three, so it's an extra
First.
bond.
Okay, very good. The more bonds, no, the greater the strength of the bond. Okay. Teka lang. Okay. What? Teka lang. Wait. Okay. So what is the central dogma of nucleic acids? Hmm. Sige nga, nabanggit mo na rin. What's the central dogma?
I only heard it in passing when I had the tutor session last week. Last
Really?
couple weeks.
Oh,
Central dogma.
don't worry. Oh, sige, I'll give you a clue. Oh, first part is R, and then second part is T, third part is T again. Hmm. O ano?
Is it transcription, replication, transcript,
Okay. So what's this? It's
replication?
sure. And then
Uh,
this
translation,
no
transcription,
transcription. And this is
translation.
correct.
Okay.
Okay. Oh. So teka. Okay, let's go down. So here's the central dogma of central dogma. Oh God, I can't again. Okay, so what happens in replication? In replication, no, you have your DNA, let's say. What's the structure of DNA?
Well, it's a double helix.
Correct. You have your DNA, and then you have to replicate it, no? There's a certain enzyme, you just have to remember, no? That cleaves the DNA into, it unzips the DNA, no?
Hmm.
So you have this, no? Okay. Once it's unzips, no? The fork is here. Replication fork. That's called replication fork, no? You have your enzymes here, no? That puts nitrogenous bases. That puts nitrogenous bases. Oh, teka. Okay. That puts nitrogenous bases on the DNA to form a what? Two new sets of DNA, no?
Yeah.
So this is called the daughter strands. Huh? So once the end of replication happens, you will have two new DNA strands. Okay. Okay. O, practical application. Where do we use where do we usually hear the concept of um DNA replication? What laboratory technique starts with P?
ECR.
Correct. Oh, what does that mean?
Um, the R means replication.
No?
No. ECR post
No. I'll give you the first two, ah. Oh, oh.
pottery. Mm, polymer chain reaction.
Oh, very good. Oh, alam mo naman eh.
Ah,
Total lang.
that's good using the first two letters. Wow. Polymer.
Oh, ganyan magturo, di katulad sa ka.
Yeah.
Anyways, paki-edit na lang po yun. Ayan, so polymerase chain reaction. So you use polymerase chain reaction if you want to um duplicate, no, the DNA and you put it in a DNA lab bank. Okay, so that's basically replication, no. You have your that's basically what happens. You untangle the DNA, you put the bases until you end the replication. So what happens with transcription? No? So transcription is the creation of what? What type of RNA? There are three, I guess.
Transcription, 3 types of RNA.
You create eRNA, mRNA, and RNA. Which of the following is the essential one for translation?
T.
No?
M?
O syempre, kung di TM. O kung di R, M. So M. This is a messenger RNA.
Wait, so tRNA is transport, right?
tRNA is transfer RNA. So from the word transfer, no, it creates RNA for transfer, like loops, etc. For rRNA, it's ribosomal. So you use the RNA for ribosomes. Oh, so the term itself. Okay. So since we have to focus on the central dogma, focus lang tayo sa messenger RNA. Okay. So you still have your, so for transcription, you have your DNA, and then this DNA will be cleaved, no? Will be cleaved at the center to create a bubble again, no? So this is a greater one. Okay. Bakit ayaw ma-select na? So once meron na yan, no, you will have your, I guess, there will be something attached here, no, to create your RNA. Your mRNA. You know? So once the process is done, when the process is done, you will have yeah. You will still have your conserved DNA, no? Siyempre, magko-close yan. Plus your mRNA. No? That's your mRNA. Okay. Oh, yun na. So, you know naman the structure of RNA, this one. So what happens when you have your mRNA? Saan pupunta yan? It will go to the ribosomes for translation. Okay. Oh, sorry, na-delete ko yun. Ayan, translation. Ay! Okay. So, let's erase the following. Yeah. Okay. So, you have your ribosome 1, 2, 3. May mga specific yan na numbers, no? And then, as your mRNA goes inside, the output will be your peptide, no? Let's say leucine, lysine, arginine, let's say, hindi ko lang kung ano yung D, I forgot. Methionine, hindi ko lang kung M yun. And then, let's say cysteine. So, it's just dapat ang dulo nito ay AUG. Okay? Kasi that's the start codon. Oh, anyways, so in translation, you have your mRNA, no? It enters your ribosomes for translation of or creation of your peptides. So once the translation ends, you will have your mature peptide, which is, let's say, ganito, which has a primary structure. So afterwards, no? After you have your primary structure, it will form bonds intermolecularly to form your secondary structure, and then tertiary structure of your protein up to quaternary. So tertiary structure is the folding of your protein, and the quaternary is the bonding of protein to protein, peptide to peptide. So I just want to emphasize lang naman yung central dogma of replication, transition, and translation. So from your DNA, you'll have your mRNA, and then you'll have your peptide. Okay? And then you will have your DNA dito. Okay. Since yan, no, there's some cases that transcription fails. What happens is from transcription it goes back to replication. What is that condition or phenomenon called?
It's when they cut it off, right?
No.
No.
So it's what?
It's mistranslation,
No, it's reverse transcription. Okay. So what happens, instead of producing an mRNA, you produce a new set of DNA, which is rapid, and this can cause cancer.
Yeah.
Okay? So cancer is caused by reverse transcription kasi you don't form peptides, no? Because of too much reverse transcription, you promote cancer in your cells. Okay. So actually, that's the central dogma. So we want to prevent this, no? Ayaw natin mangyari yan. We want to prevent that. Kiss tayo dyan. But basically, no, that basically marami pang mga post-translational modifications, especially in protein, maraming binding, daming conditions. How would replication happen? But basically, to get a gist of the central dogma, ayan na nangyayari. So replication, you have your DNA, parent DNA will form N for the parent. So your daughter cells will be what? How many N? N plus 1, N plus 2, N plus what? It depends, no? If, for example, you started with 1, you will have 2. So that is what? N plus 1. But if you start with 2, you will end with how many?
4.
4. So the formula is N raised to, I guess, 2, right? Or let's say if you have 6, how many will you produce? 36.
6.
Right? So that's 6 raised to 2. Correct? Okay. So, if the professor tells you how many daughter DNA will be produced from 56 DNA, what's the answer? Just 56 squared. Okay?
Do it through my head.
Sabihin mo lang sa prof mo, 56 squared, sir. I don't have my calculator with me, but I know it's 56 squared. Ayan ka na. Okay. Ayun. And then, ano pa ang important with DNA? So, I'll clear the, you take a screenshot of the, central dogma. Para later, hindi ka na mag-refer sa PowerPoint.
Okay.
Clear ka na lang. Are you done?
Yes.
Share on. Sige. What's next? Ano pang important dito? Okay, let's see. Ayan. So, sabi naman dito, major function, storage and expression of genomic information, and encodes the information of cells to make proteins. So, from the DNA, you make your RNA to make your proteins. Yun yung kanina, no? This is translation. This is from transcription to translation. A relative nucleic acid RNA comes in different molecular forms that play multiple cellular roles, including protein synthesis. So a while ago, I told you about messenger RNA to synthesize protein. Okay? Ano pang gusto mo? RNA, DNA. O, pili ka.
I'm
O,
reading
tingin.
through.
But
Uh,
I would like to emphasize, no? So this is your ribosome.
yeah,
This is your mRNA.
yeah.
And these are your tRNA. They transfer um they transfer polypep nitrogenous bases. So this is your machinery. So anyways, let's see. I'll show you the central dogma. Uh, central dogma schematic. Okay? Ayan. Okay, you have your DNA, then it creates your mRNA, no, for transcription, and then you'll have your translation. Okay, ayan. So your DNA, oh, may fork ka dyan, mRNA, and then AUG stands for your methionine, which is your stop codon. What are your stop codons? Uga, uwa, meron
Wow.
pang isa I forgot. Oh, basta aralin mo na lang yon. When you say stop, you stop the creation of your polypeptide
Yeah,
in translation.
it gets cut.
Okay? Ano pa ba? Ano pang essential? Teka, ayaw niya mag-zoom out. Okay, so ato. There are other things that happen, no? You can happen. Sorry. Ito. Yan, oh, ang dami nangyayari. So, transcription, reverse transcription. Sorry. So, from your RNA to your DNA, reverse transcription. So, ayaw natin yan.
Hmm.
So, this is your DNA. You replicate your DNA, no? And then, ito yung DNA mo. For transcription, you will form your RNA, translation, your protein. So, this protein is folded, I think, secondary. So, what are the structures of protein? Protein structures. Or do you want to further discuss DNA or nucleic acids?
Hmm.
Teka, nucleic acids module. Let's see, dito sa... So from here, I'll ask you, no, um, I will ask you questions. Oh, mga protein. So I guess you know those. Oh, this is the structure proteins, no? So you have your primary structure, which is just a 2D structure. Secondary, you have your bonding of your carbon to your side chains. It can be alpha helix, it can be pleated sheets. So from helix, no, it's a helical structure. From sheets, it's a beta sheet. So tertiary, like for example, formation of your heme, you fold it, no, within the side chains. And then quaternary, you have this. It forms quaternary structure to other proteins. And then ano pa ba? Okay. What is the concept where a folded protein becomes unfolded? What do you call that term? It starts with letter D.
Denaturation.
Correct. Denaturation. Okay. Okay. Pagpabalik, ang denaturation ay pag ganun. From folded to unfolded. So, clear natin. So, let's go here. Shoot. Let's select. Okay. 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 Ano ba importante dito? So, that's important, no? Hydrogen bond.
Hmm.
You have your amino bond. You have your bonding here. So, yan nangyayari sa folding. So, you have your binding site. And then, medyo malayo na to. Balik na lang tayo sa DNA. Nucleic acids. Let's see. What do you like? DNA, RNA? We still have 20 minutes.
I just realized we haven't even discussed nucleic acids yet in the actual class.
Ah, really?
Yeah,
Oh,
so
yeah.
we're being a bit advanced instead of reviewing.
Oh, anyways, oh, sige. Let's see DNA.
So I don't really
Oh,
know where we're going. I don't really know.
oh, that's basically it. No, mga dinidiscuss ko lang sa'yo.
Hmm.
Oh, that's the structure of your nucleic acids. I mean your nitrogenous base. Okay, so let's emphasize on the structure. So you have your major groove, no? So the major groove is the groove that is bigger, minor maliit. Okay? Um, annotate. I'll clear the annotations muna. Okay? Parang mas okay sa akin ng ano. Okay rin pala sa akin ng online tutorial. Before kasi mas gusto ko. Maybe pag face to face we should also have projector. Ma'am
Yeah.
Jo? Hindi. Miss Jo, nandiyan ka po? Oh, busy si ma'am. Anyways, during siguro i-recommend ko rin yon during the tutorials, meron tayong projector and I'll just show you not just with your case, with others. So, para maganda, mabilis ang
No,
discussion.
only me.
Hindi, may iba rin na mas okay reference. Para
Yeah,
para
this is
ano,
nice also. Yeah.
okay. So, sugar phosphate backbone. So, you have your okay. So, let's zoom in. Sugar phosphate backbone. So, basically, here's your sugar phosphate backbone. Um, ayun na niya mag-zoom. So, you have your DNA, your sense transform 5' to 3', no?
Hmm.
So, what does the prime mean? Yung 5' to 3', ano yan? That's the, ano yan? An idea?
I
Any
know they
idea?
have to be like five has to be facing a three. It can't be five facing a five. That's what I
Yeah.
remember.
So, basically, this is the number of, uh, this is the number where the phosphate group is bonded. So, the carbon where the phosphate group, no? So, this
Hmm.
is carbon 1, 2, 3, 4, and 5. No. Um, no. 1, 2, 3. Bakit nga? Dapat 1, 2, 1, 2, 3, 4, 5. 1, 2.
Oh yeah, I forgot that. So you count from the carbon, right? And then
Yeah, 1. Basically, that's it. Nakalimutan ko na. Hindi naman ako bio major. So, yun lang yun. So, yun lang yun. You just count. And then, oh, ito yung sinasabi ko sa'yo. What group is this?
the phosphate.
Oh, yun na. Obviously. So, it can undergo resonance, no? So, gumagalaw yung electrons niyan. That's why it's a very, very energetic molecule.
Hmm.
And then, ano pa ba kailangan dito? Okay. Ayan. So, ito pala, basically, the nucleotide, no? Nucleotide. So, what's the difference of a nucleotide versus a nucleoside? Do you have idea? Anong difference nun?
Nucleoside. No, no.
So, search natin. Hindi ko rin alam. I mean, I just forgot. Nucleoside. Okay. So, your nucleoside is just what? A nitrogenous base bound to a pentose sugar ribose. Okay. So, sige. Let's see.
Space bound to sugar.
Clear all drawings. Ayan. Ayan lang. So, if you have, you have your, so, wala kang phosphate group for
Oh, okay.
nucleotide. Okay? But for nucleotide, you have your phosphate group.
Yeah.
Embedded. So this is your nucleoside. Advance ka masyado, Gerard.
I know.
Tapos, ayun, explain naman na yan. Ano pa, what's next? Let's go to the RNA. 15 minutes. RNA. So, ribonucleic acids. Okay. As you can see, here's your transfer RNA. Messenger RNA usually are linear, no? And transfer RNA are placed from there. You have your transfer. So, what can you observe with your tRNA? What forms in tRNA? It starts with L and P.
L and P. The two forms of a transfer RNA. Loops.
Oh, correct. The first one is
Loops.
loops. Teka lang, ayaw na naman ayun. Loops and pins.
Pins.
So, at transfer RNA from those, no, you have your nitrogenous base and you transfer them to your messenger RNA for protein coding. Okay.
Mm.
So this tRNA enters your ribosomal RNA, wherein at the center of your ribosomal RNA, there let's say at the center, okay, at the center you have this, let's say, and then your tRNA and then your group, no, it will pair. So this pairing are A is to T, U is to, let's say, RNA na to, no? So A is to U, G is to C. You get my point? So,
Yes.
let's say ito yun. Ito yun. So, yung mRNA mo, you have your, what is C? Thymine. Guanine.
Guanine.
Cytosine.
Yeah.
Ay, adenine, sorry. Adenine. Uracil, what? Adenine as well. Right?
Yeah.
Once this form, ano itong TAA? So, dun tayo sa table of codons. Ayan. Ayan. CGU is TAA. TAA. So TAA is AUU, right?
Yeah.
So TAA is AUU. So this will be AUU. TAA is AUU, right?
Yeah.
So what would be the amino acid formed with AUU? Sige nga. Using context. Based on our discussion, no? AUU, saan yan?
It's
First,
there.
A?
There's the A, U, Ili.
Oo. That is isoleucine.
Which
Okay? Which is an amino acid. Okay?
Okay.
Okay. So, ganun lang yung central dogma from RNA, from transcription to translation. Naintindihan mo siya on a practical sense.
Yes.
So, kasi explain sa books, this is how it enters. Ako, shortcut na binigay ko sa'yo. Okay. Ano pa ang kailangan dito? So, that's the major structure of those. As you can see, no, sugar nucleoside lang siya. Connected to sugar, you have your pentose sugar, and then you have your nitrogenous base. Okay. Sabi dito, 10, 10, 10, 10, 10, each absolutely fundamental functions, 10, 10, 10, 10, 10, whatever. O, dito tayo, RNA yun, no? Transcription. So, nauna pala tayo, nag-translation tayo agad. Anyways, let's go to transcription. 420. So, this is what happens in transcription. It happens in your nucleus. So, basically, you have your DNA. This is your replication fork. And this is the, as the as the nitrogenous bases are added to your parent DNA, no, to form your messenger RNA, you form your RNA. Ayan. And your mRNA, no, goes out of your nucleus from the nuclear envelope. Nuclear ano yan eh. Nuclear something. And then your mRNA can be used for transcription in your ribosomes. Okay? So, ayan siya actually. RNA polymerase, transcription. Polymerase, from the term polymerase, you create RNA. Once it stops, you create your messenger RNA, no? So, when you create your messenger RNA, you have your exons and introns. So the exons are included, no? Introns shall not be included. Not included in the processed messenger RNA. So in the sa batang mRNA, you have your exons and introns. These are removed, no? These are removed to form your processed mRNA. Okay. So after it's processed, no, when it can be used to it goes to the cytoplasm, no? It goes to the cytoplasm, no, the nucleopore. It goes to the cytoplasm and it will be captured by it may be degraded, no? Pwede siyang sirain, pwede siyang i-capture ng ribosome RNA. Yun lang. Messenger RNA, let's see. So 8 minutes. Okay, so your mRNA, actually yun na yun. Gene expression na lang. Sige. Last. Your gene expression is this. So this is basically your gene expression. No, from transcription, lalabas ang messenger process, no, to your cytoplasm, and the ribosome RNA together with your translational RNA, your transfer RNA will form your protein. So this is your protein pala. Teka lang ah. This is your protein. Ito yung protein. Ito yung sinasabi ko kanina. Once it enters your rRNA, it will transfer here, no? And once it transfer, you will form this polypeptide. Okay? So once it matures, it will go out to form your protein. So yung protein, it's folded. So usually after nito, magiging ganyan siya. No? Okay. So basically, that's the shortcut for nucleic acids and gene expression. So basically, I gave you the protein and then that's the summary. That's a overview of nucleic acids and gene expression.
Okay.
So I guess sabi ni Miss Cho, we are about to end kasi hanggang 4 lang pala. Kasi
Okay.
nasa Zoom 4:30. Anyways, wala namang problem as long as you understood naman, no, the concept. So you're more advanced than your classmates.
I'm slightly advanced.
I mean, when you read or you read further, you'll understand. Ito yung sinasabi ni Kuya. So you know the terms, we'll know what is an RNA polymerase. So yun, from the term polymerase, you create a polymer of the RNA. O Gerard, you can go na siguro. Mamaya.
Okay.
Okay, thank you.
Bye.